All right, I want to talk about section 7.4, and we're talking about the regression equation. So we just kind of looked in 7.1 about some scatter plots and figured out what the correlation and that kind of stuff meant. And now we're going to try to figure out how to approximate a best fit straight line or a line of best fit, or use least squares regression. Lots of different ways this is labeled. So here you have y equals a plus bx. You might be more used to seeing this as y equals like b plus mx, or here y equals bx plus a. And b is the slope here. You'll notice here in this formula I snagged, we use m, and b is the y-intercept. That's a little bit more accepted. It doesn't really matter what we label these, but we do need to know the one that we multiply by our dependent variable, excuse me, our independent variable here, x, that's our slope, and this one here is the y-intercept. So we're going to do some problems, and then we'll talk about interpreting what the slope actually means, just like we interpreted the regression, and those kinds of things. A couple of notes in here in the text. You can read this. This is just a stolen section from your textbook. If we're going to make predictions from our line of best fit, we want to make sure that our predictions are falling in the interval in which we have data. So we don't necessarily have the ability to say, hey, this is going to be useful larger than our data set or smaller than our data set, but we could still use it as a guess if we wanted to. It just might not be a very good guess. So let's look at some questions here. The first one to come up, part of it here. Based on the data shown below, calculate the regression line. Each value to 3 decimal places. Round each answer to 3 decimal places. So here we have it. Now, I know I've been telling people you're going to want to pay special, and there are those of you that really don't want to. If you end up, oh boy, what happened? I don't know what I clicked right there. That was an unusual option. Paste special, and then usually I have text here that said something about bitmap and blah, 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 blah. Anyway, okay, so if I want to make a graph of this, and I think we do some graphing in this section or the next, I'll go here and I'll do insert, and I go over here to charts. A scatter plot is a good graph here, and this kind of plots our data. You'll have some questions that actually ask you to do a little bit of the scatter plot. I think I'm going to make this larger here, just so we can see it better and have a little more room to work in Excel. Okay, so this is what our plot looks like, and if I want to go through and try to figure out what the line is here, I could sort of draw one. I actually don't know if it will let me draw on here. It will, sometimes when you draw on images. It's kind of just a guess of what that one might look like. But if I want to, I can go up to my formula here and find out what the slope and the y-intercept are. Now you'll notice here I have some things. X, the sum of xy, sum of x, the sum of y, sum of x squared, sum of y squared. So if I just kind of go through here and figure out, I need x squareds eventually, I need y squareds eventually, and I need xy's, or xy's, excuse me. So finding those here, I can take my x's, and then that shift 6 and the caret. Here, grab my y, again, shift 6 and the caret, and then xy. And if I'm just grabbing the data in the cells, I can grab these and double click here or drag it down, and it fills those out. Now notice these sigmas here, let us know we want the sums. So I'm going to go ahead and calculate those, and we can use the sum function in Excel. I don't know what we had there, sorry. Sum, be a little touchy. And then I can drag this over, and I've got the sums of all of those. So if I want to find my slope, m, it's going to be equal to, I've got n, well, n here, I've got 1 through 6. I should have probably put n on here somewhere, so let me back out and add n. That's a good idea to know how many numbers we have in our data set. And it's talking about our pairs here, so we've got 6 pairs, so n will be 6. So here equals 6 times the sum of all the xy's, that's this right here, minus the sum of all the x times the sum of all the y's. And actually, I need this in parentheses because that is the numerator. You could do that in a step if you wanted to. And then for our denominator, we've got n. I'm going to open parentheses here. N times the sum of all the x squared, so that's this cell, minus the sum of all the x's, and then that quantity gets squared. So I think I've got them all there, subtraction, all that fun stuff. So I've got now the slope and then the y-intercept, and I'm using m and b, not a and b from the other thing. Looks like I have a numerator here, so I've got the sum of all the y's, that's this one, minus, we just found m, times the sum of all the x's, that's this one here, and then we divide that by n. So there we go. We've got some answers here. Now, let me grab this eraser and see if I can get rid of this really quickly. This is one way to do it. If you go over to your scatter plot and you hit the little plus here, there's an option for a trend line. If you hit this little arrow over here, there's more options. Linear is one that we want, and if I go over here to where it says display equation on the chart, I get this here, and if I click on this, I can kind of drag it around. I think if I double click in here, oh, maybe I need to select all of this stuff. I can make this a little bit bigger so it's easier to see. And you'll notice here, using the trend line function, I've got it here. Now this might not always give you all the decimals that you want, and so if you go over on your format trend line, there's kind of a way to figure out, let's see, text. Okay, I'm back here. I believe I have it figured out here. If I click inside my equation here and go format trend line labels, if I go to this category here and choose number, then I can set some decimal places. And if I want to have it accurate up to 4, I can make 5 there, which might be what I had already. No, it doesn't quite look like it. And then I should be able to get out of here. I might need to make this a little bit larger. Well, for whatever reason, I'm not getting a 5th here. Oh, maybe it terminates. Anyway, a lot of these only have to be accurate to 4 decimal places. So if we get there, this is one of those things that if you have a computer, it might be set up a little different. Sometimes there's lots of different ways to get here. But you want to make sure you have some decimal places of accuracy there if you want to do that, or you can use this system here to find it as accurate as possible. We can kind of drag this over and see. Our 3's just keep repeating. Anyway, if I go back here to try to finish up my question, I have an answer here of, and I just need to make sure I put the slope where it should be. And up here it says each value to 3 decimal places. So 2, 5, 8. And that 8 is followed by a 5. So I'm going to make that 8 a 9. And then 5.373 and a bunch of 3's. So here we are. So as the first question worked out, kind of the short way, the long way, and then the short way. I'll come back and do a few more examples here.